Hello viewers, welcome back to my channel. Today I will be talking about how to create the Define.xml using the Pinnacle 21 tool. So right now I'm using the Pinnacle 21 community version tool. You can also use the Pinnacle Enterprise to achieve this. So there are two steps. First is to generate the Define.xml spec, and then the second step is using the spec to generate the define. Pinnacle 21 helps to create this spec also. So let's see how we can create the define.xml spec using the Pinnacle 21. To generate this spec using Pinnacle 21, we should have the XPT format of the dataset for the study. So right now, I will be creating the define.xml for the SDTM data. So I will be using the SDTM XPT data files. So right now I will be uploading all the SDTM data which is present in my study in the XPT format in this. So you can browse to the location and select all the data sets from the location and upload it. And you can see that right now I have 28 files in this study. The next step is that we have to mention the SDTM IG version which we have used in our study. So you can see that in the drop down, there are many SDTM IG versions here. You can see that we have Adam IG versions also because the same tool can be used to generate the Adam define.xml as well. But since we are creating the SDTM define right now, and in my study, I have used the 3.3 IG version, so I will be selecting SDTM IG 3.3. So doing all these steps, we will then click on the create button and you can see that the Pinnacle has started generating the XML spec here. So it has completed. Let's open the spec. So here you can see that a spec is created here by the Pinnacle, and please note that this spec is only a draft of the define.xml spec, and it is not the complete version of the define.xml spec. We will have to modify a few things here to generate the define.xml using this spec. Pinnacle only helps to populate the information which it can gather from the information which we have uploaded. Since we have uploaded only the XPT dataset and the SDTM IG version, only that information will be used to create the spec. The rest of the information we will have to fill either manually, or if you have any macros, SDTM or SAS macro created, you can use that macro, run that macro, and that will fill the required other information automatically. Normally, in most of the organization, they do have a macro which they will run and they will generate the defined spec. And then using the defined spec, they can create the define XML as well. So let's see right now if in case we will have to create the define manually after generating the draft version of the define.xml spec from the Pinnacle, how we can achieve that. So now here the first tab in the spec is for the define tab. So here you can see that since the Pinnacle had only the information of SDTM IG version, which is being used in our study, that is being filled by Pinnacle already. So here they have mentioned that the SDTM IG is the standard name, the standard version is 3.3. But since this information of the study name, study description, or protocol name was not given to Pinnacle, it is kept as empty. We will have to populate it from our end while modifying this draft version. Coming to the dataset tab, you can see here that the dataset tab is having the information of all the datasets which are being used in our study, and here they are given the information of the dataset, its label, the class to which it belongs, the structure of that dataset, the key variables, and again, standard is, this is the information which represent that the SDTM IG version 3.3 is being used. Please note that these two columns, which is the standard and has no data column, are the fields which are newly added, and it is only needs to be filled when you are using the define 2.1 version to generate the XML. If you are using any previous versions from define 2.1, you do not need to fill this information. So this is the pre-filled information. We will be looking how to fill the remaining information in few minutes, but right now I'm just showing you the information which is filled by Pinnacle from the information which we have passed in the generation of defined spec. So next is the variable tab. In this variable tab, again, you can see that, as the name suggests, that it will give the information of all the variables in all the data sets which we have in the dataset tab. So taking an example of the dataset A, you can see that all the variables which we have in our study in A domain are present here, and their respective label data type is also mentioned here. The length information is the information which the Pinnacle will read from the XPT file. In XPT file, for A data, the Pinnacle can read that this particular variable is having what length and what is the data type. So using that information, these two fields, the data type and length, is being filled in Pinnacle. The next field which is filled is the mandatory field. This is the field which will be filled using the information of SDTM IG 3.3. If you will see that the variables which are marked as yes, mandatory as yes, are the fields which are the required fields of your SDTM domain variables. You might remember that we have three types of category, which is required, expected, or permissible for each variables defined, right? So if a particular variable is required, then that particular variable will always have the field of mandatory as yes. For the permissible or expected, it will have the value of no. So remaining fields are the fields which we have to fill it from our end, which is the assigned value, code list, common origin, source, page, method, and predecessor. We will see all what these all fields mean and how we can populate it. The next information, which is again filled using the SDTM IG information, is the role information, that what was the role of the variable which is being displayed in this particular row. Again, there are 5 types of role variables, which are the topic variables, identifiers, variable qualifiers, record qualifiers, timing variables, and so on. So all that information is being populated here for each and every variable by Pinnacle. Coming on to the value level or the code list, dictionaries, methods, comments, and documents. All these fields will be kept as missing when the Pinnacle generate the spec, because this information is not available for Pinnacle right now to be filled. So this is the information which we have to fill it manually. So let's see how we can fill these fields manually here. So right now, before creating this video, I have already filled the required information in this report, and I will be now explaining how to fill all this information. Let's go to the first domain. Here, as we have seen that in the Pinnacle version of Pinnacle draft spec, these information of the study name, study description, and protocol name was kept as missing. So right now, I have entered the study name, the description, or the protocol name. All this information you can get from your protocol, your SAP of the study. So you can use that document to fill the study name, study description, and the protocol name. Next is the dataset. Here, again, the most of the fields were already populated by the Pinnacle, but there are few other things which are which were not populated. For example, the field of comment. Here, you can see that for few of the domains, the comment is mentioned. What does this field means? If in our study we have any particular comment for a particular domain, then what we can mention that comment in our defined using one particular ID. Taking an example of this scenario, which is the FA2. So right now, in this study, we have a one particular comment for FA domain, which and we can populate the comment giving a ID of FA2 in the comment column of the respective tab. But the description of what the comment is will go in the comments tab. So if you go in the comments tab for the in this, we have the ID, the description, the documents or the pages information. So right now, for FA2, we have this description that the FA domain consists finding about injection sites, reactions, adverse event. So this was our comment for FA domain. So what we have done is we have given an ID to FA domain comment, and the same ID will be populated in our comments tab with the description of it in the description column. Please make sure that you are using the correct ID in both of the tabs, which is the comments tab as well as the other respective tab in the comments column. Similarly, for the remaining domains also, if we have any comment, we can generate a new comment ID and we can mention the comment for that accordingly. There is no hard and fast rule that what is the comment ID, the naming of any comment ID. It is the code, you can say any ID, any code words which you can use, and the same code will be mentioned in our comments tab. But make sure that no two comments are having the same ID. The ID and the description should be in the 1-to-1 mapping ratio, which means that for each distinct ID, we should have only one description. So in this way, we have the dataset tab created. So next is the variable tab. Here, apart from the fields which were already filled by the Pinnacle, the other information which we have to fill manually was the code list tab, the origin, the source, or again, the comments. Here you can see in the code list column, we have given that if for a particular variable in that particular data set, any code list was being applied. So if any code list is being applied on a variable, then the name of that code list will go in the code list column. You might have observed that in SDTM IG, the domain variable for each data set is having a code list domain. So right now, I am using the domain underscore A code list for the domain variable, and in the code list tab, I have given the domain underscore A as the ID, which is same as the code list name here, ID mentioned here. And the other details when we are defining any code list is here. So in this scenario, domain is the SDTM domain abbreviation code list as per the SDTM terminology. So that is the name here which we have given. Apart from that, the NCI code list code will be the domain SDTM domain abbreviation code, which you can get again from the SDTM terminology. The data type of this code list, whether it was a text code data or it is a correct integer data that you can mention in the data type. The terminology column will have the information of the SDTM terminology version. Every 3 months, we do have a new SDTM terminology version coming up. So right now in this study, the SDTM December 2020 version was used. So the same version is being mentioned in the terminology column. In case your study is using any prior version or any newer version, then you make sure that you mention the terminology accordingly. You can get this version from the Excel sheet SDTM terminology sheet tab name, that what is the terminology name here. Again, if we do have any comments, that can be populated in the comments tab, but right now I do not have any comment for my domain code list, so I have not given anything. Then the other thing is the term. Again, domain code list is say I have applied on the domain variable for a data set. So the term will be a here, and its description will go in the decoded value, which is the adverse event. So in this way, the term and the decoded value will be populated. The next thing is the NCI term code. So the NCI code list code and the NCI term code are the information which you will get from the SDTM terminology sheet. Under the NCI code list code, which is the code for the SDTM domain abbreviation, for each domain, you will have a NCI term code mentioned. So using that SDTM terminology sheet, you can get that for AE, what is the NCI term code. So we can have this information from the SDTM terminology for AE and for other domains as well. So in this way, you can create a code list. So now let's see for the remaining ones also. So as we are aware that these are the variables which are the Medra code list is being applied. So for these variables of A, we have given the code list as Medra. And when we see in this, okay, so for Medra, we will not have the information populated in the code list, but for the code list apart from Medra or Hoodruck will be mentioned in a code list tab, because Medra is going to have all the system organ class, high level term, group level term, low level term information. So all that information will not be populated in code list. But apart from the Medra, every other code list will be populated in our code list tab. Let's see for the AE severity here. So here you can see that for AE severity, which is again the severity on intensity scale for adverse event, is the name of the code list. We have the NCI code list. And the terms in this code list are mild, moderate, severe with their respective decoded values in the prop case. So similarly, if you see here that for each and every code list which is being used in our study, we have one section for that code list. For the ACN code list being used on the AE ACN variable, we have an ACN code list, and we have the terms and their respective decoded values, the NCI code term and the NCI code list code. These are the information which you will get from the SDTM terminology. Now, if you can see, there are very few code lists for which you do not have the terminology mentioned. So what does that mean? So sometimes in our study, there are few information for which we have a particular format being applied in our study, but it is not exactly a code list, but some format. So for example, in case of ARM code, we gave a code to to the treatment in our study, and the description of that treatment is given in our ARM. So in that scenario, that particular format acts as a code list. So here we are giving that information also in our code list tab. So you can see that in this study, there are 3 arms. So the coded value of arm is going in the arm code variable. So we have the term arm code with the decoded values in the term column, whereas the decoded value in the decoded value column. Same is the case that we do have the decoded values in the arm code list as well. Please note that the NCI term code and the NCI code list code or the terminology information are kept as missing because this is something which is sponsor defined and it is not the CDISC defined SDTM terminology. So similarly, if you can see that there is another code list which we have, or code list, or you can have format which we have here. So this is another one for which we do have the values as recalled and not recalled coming from the data, but it is being changed to the prop case to recalled and not collected. Another example of such scenario is the element. So here you can see in the trial element data set, you will have the element column. This is again the information which is study specific, and depending on study, it will differ. It is not a standard, it is not a global standard which will be followed for each and every study. Because of that, it is not a part of your SDTM terminology, but it is defined as a sponsor defined code list. So in this example, you can see that in the element, the element is the ID which we have given, and this code list will be applied on the element variables in the TE domain or even in the SE domain. So it will have the information of the elements in our study. So here since we do not have any we do have a variable ET code, which is the coded values of the element. So you can see that the ET code is having the element code and their description is coming in the decoded value, and the same descripted value is the element code list here. So in this way, you can populate the code list tab, and all the IDs which you are giving for any code list in the code list tab should match with the code list ID which you have given in the code list column. If you are applying any NY code list which is yes and no, then that particular code list will be mentioned in the code list column, and the respective values which is no or yes values will come in the code list tab. So coming on to the next column, which is comments. Right now, since it is a SGTM defined, we do not need to fill this common column because this column is only specifically used for the Adam dataset. So now coming on to the origin. In case of origin, any variable can have one of the five origin mentioned. The five origins which any variable can have is protocol assigned, derived, or collected, or the EDT transfer, or some predecessor information. So right now you can see that we have the origin populated. So now how we going to identify what is the origin? So for the protocol, for the variables which are of protocol origin, the information which is populated in that particular variable will come from the protocol. For example, the protocol origin is being applied on this study ID variable. So study ID is the information which we get from the protocol. That in each protocol, we do mention that, okay, what is this study and what is this study ID. So the information comes from protocol. The next is assigned. Any variable for which the value is assigned by the sponsor will have the origin as assigned. In this example, right now, the domain variable is having the origin as assigned because we are giving the information of domain as A, which is assigned by the sponsor. Similarly, the uSubject ID will also have the information of assigned because we are assigning a uSubject ID to each subject ID, each subject or the patient enrolled in our study. So this is something which we are giving from our end. That's why it is being mentioned as assigned. The another thing is derived. So any variable which is being derived after applying some derivation logic will have the information of origin as derived. You might see that sequence right now is given the origin as derived because we derive the sequence. We apply that we have to increment the sequence value by 1 for each new record. Some logic like that is mentioned there, right? So that derivation logic will come in my methods, and if you see the origin derived, then all the variables which are having the derived origin will have a method being mentioned there. So coming to the next origin, that is the collected origin. Any variable which is collected on CRF will have the origin as collected. And the page on which this information was collected on the CRF will be mentioned in the pages column. So right now you can see that this particular variable, which is the variable a link ID, is given the origin of collected, and if you see the CRF, this a link ID variable is being annotated on page number 22 and 23. Let's see if we have the ACRF and we can see. So let's go 23 column. So here you can see, right now I'm showing you the ACRF for this study, and you can see that on 23 page number of the CRF, which was mentioned in our define, that we have the A link ID being annotated in this particular page. If we see on 22 as well, you will have the A link ID annotated on this page as well. So you have mentioned that this information was collected on CRF page number 22 and 23. The pages which we are mentioned on in the page column should be in the increasing order. Means if right now this information was collected on page number 22 and 23, we have to mention it in the ascending order. The page number should be mentioned on the in the ascending order, that is 22 and 23. It should not be 23, 22 or any random order. It should be in the increasing order only. Again, as we have seen for the dataset level, we have the comments for the variable level as well. If we do have any comment for particular variable of a domain, we can give an ID, and the description of that comment will go in our comments tab. Right now we have a comment ID A3, and A3 is being applied on the column AELLT as well as AELLT CD. So let's see what's the comment. The comment is that as you know that these are the coding variables. So we have a comment that right now the coding variables are not populated due to the proprietary coding dictionary, but the variables are included as they are expected or required. So right now in our study, these Medra code variables are not having any particular value, but they are being kept in the data set because these are either the required or the expected variables. So because of that, we do mention it in our define, but the information that the variable that whether these variables have any data or not will have the information that these data are null. So that's why has no data column is populated as yes right now, because in this study right now coding Medra coding has been not done. Okay, so this way you can create the variables tab that you have to mention each code list origin. If the origin is collected, then the page numbers, and if it is method is being, as I mentioned, that if the origin is derived, then we do have a derivation logic or a derivation method. So for that method, you will give a ID similar to comments in the method method column, and the description of the method used will be going into the methods tab. Let's see right now the SAQ. Right now, we have applied the SAQ method to the A sequence variable. And what was the method? We have the ID here. We have given a description of the ID, which is the algorithm to derive the SAQ variable. And the derivation for this variable is that unique subject number with a subject unique sequence number with a subject within a subject restarting at 1 for each subject applied to sorted data. So similarly, you can see that for any variables which were derived in our study, we will have a method applied for that, and we have a method ID mentioned here. So if I see, there are few variables for which we have the region as derived, and we have the method mentioned. And if you see the method ID here, we will have the description of that method as well. Another point to notice is that let's see the sequence method. So here you see that the sequence ID, the method which is the sequence method, is being applied on many variables in the different domains. Why we have the same method? Because the logic of the sequence generation is common to all these sequence numbers. So for A sequence, CM sequence, or so on, the derivation of this sequence is same. So because of that, we have given the method as sequence, which is once for, and it will be defined once in the method tab. Similarly, let's see an example of another such type of method. Let's see the epoch. So again, the epoch, since we have an epoch variable in all of these domains, but the derivation logic for the epoch remains same for each domain. So we have given one ID for epoch derivation, and using the one same epoch ID in our method tab, and giving the description of the method. Now you can see that for epoch derivation, there is the description mentioned that epoch from SC, where the date is greater than the SC start date and date is less than the SC end date, will be the derivation logic. So in this way, you will have to mention all the method IDs for all the variables where the origin is derived. And if it is the origin is collected, then we will have the page number of the CRF where it was annotated will be populated. You have seen this column, the source column. So in this source column, you might notice that we are having the information whether it is sponsor or investigator. Again, here, if it is collected in the CRF, then since the CRF is being used by the investigator at this site, and he fills the information in the CRF or the digital data where the CRF is in the online form, then that information was collected by the investigator. So because of this reason, the variables having the origin of collected will have the source as investigator, whereas for the remaining variables, whether the origin was assigned, derived, protocol, we will have the source as sponsor, because all this information is coming from the sponsor, that what value should be given to these particular variables. Or even if we are applying any derivation, then sponsor tells us that, okay, this particular derivation is it should be used to derive this particular variable. Another thing you might have noticed here is that there are few variables for which the origin is missing. So let's see why that is the case. So right now, here you can see the A term is one of the variable which is having the origin as missing. Why it is so? Because there will be a scenario that A term can have multiple origin in our study. So if any particular variable is having multiple origins, then in the variables tab, the origin will be kept as missing. So if you see the variables which are having the missing origin, there are few of them. Here, the race, DS term, DS decode, all these variables are having multiple origins, because of which the origin is kept as null in the origin tab. So we will come to know that what is the multiple origin, but for that we will have to move to the values level tab. So this was all regarding the variables tab. Let's move to the value level tab. Now in the value level tab, we will give the information of all the variables for which we have the different data type being defined for different scenarios. What does that means is, taking an example here, the first example is the A term. As you might have noticed that the A term origin was missing, which implies that this variable have multiple origins. So how it can be the case? So now here in the variables tab, we will mention the data set, the variables, and then the where clause. Now, what does this where clause means? In this where clause, we are giving the scenario that when A term is equals to injection site reaction, in that for that particular records, the data type of A term is text, length is 200, but the origin is assigned. And we have given the source as sponsor. This was also annotated in our CRF page. So let's go to CRF page number 23 back and see what's the case here. We are talking about A term. So here you can see that in this term, the information of injection site reaction, it is already pre-filled in the CRF form. It is not a free field where you can mention any value for the A term, but it is going to have only the pre-filled information, that is the injection site reaction. So because of that, it is having the origin of assigned, because it is assigned in the CRF. It is not going to be filled by the investigator. Since it is assigned by this already assigned in the CRF, it is having the origin of assigned, and it was assigned by sponsor because these forms are being created by the sponsor. But then again, there is another case where the A term is not equal to injection site reaction. So for that scenario, the origin is collected, and it is collected on CRF page number 22. So let's go on page number 22 and see what's the difference. Here you can see the A term is annotated on a free text field, which means that the investigator can fill the A term information from here, and it is not pre-filled. So because of that, the origin is collected, and since it is filled by investigator, the source is investigator. So as now we understand that the A term is having two different origin, whether it was assigned by the investigator in the CRF form, or whether it was filled by the whether it was filled by the investigator in the CRF form, or it was pre-assigned by the sponsor in the CRF form. Because of that, we have the two cases. That one case is where the A term is equals to injection site. Another case is where the A term is not equal to injection site reactions. So that's why we have these two rows created for the A term. Similarly, for the race also, in the DM dataset for race, you might have noticed that we can have either the race equal to multiple, or we can have the race not equal to multiple. So what's the difference in the both of these scenarios? So in this both scenarios, when race is not equal to multiple, the length depends upon the value of the race. So the race can be Asian, black, white, African American, or and so on, depending what is the race. So because of that, we have a length in this study based on the data values which is present for the case when race was not equal to multiple. The length was 21, and when the race was equals to multiple, which means the race value is having the value of multiple, which is of 8 character length, my length of that particular record for the length of that particular race will have the will is 8. So here, because this race variable is having two different length defined for two different scenarios, we have to distinguish those two scenarios in the value level tab, where the where clause will give the information that which two scenarios are the ones where it has the different length. Similarly, you can see that for these two different scenarios, we do have the difference in the code list as well as origin and source also. So all this information will be populated accordingly in the value level. Same is the case what we have seen for the term and race will be the case for decode, DS decode or DS term as well. Another thing is for the ORRES variables. For the ORRES variables, if in a particular domain we have the length or data type or the code list as consistent for all the tests, then we can have only one record. But in scenarios where we have different code list being applied, in that scenario we will have different rows created in the value level. For example, for FAORRES, we do have two scenarios that when FA test city is equals to SAV, in that scenario, we have the code list of FASCV applied. And similarly, when the ORRES is equals to occur, in that scenario, since the different code list is being applied, we have a FA occur as the code list mentioned. Another difference in these two is that the data type, in the data type, the length of the result variable, which is the FAORRES, is having different length. In one scenario, it is having the length of 8, another is 1. You might notice that if FA test CDs occur, that means we will have the result of Y or N. So the length is 1 in that scenario. Same is the case for this standard character result for FA domain, and you can see that the ORRES is also being created for the other finding domains here. Another is variable for which we have the record is the unit. So in LB ORRES U, which is the originally captured unit, for depending upon the test CD, you can have multiple test CDs having the same unit. So in that scenario, in the where clause, you will mention the LB test in, and in brackets, you will mention all the test CD which are having the that particular unit. So here, since we have a different unit for all these tests, we have created one record and we are giving the code list here, and in the code list you will see the values of the unit being used. So here for this particular unit code list for LP, we have the term FL, which is femtoliter. So in this way, you can create the value level tab for all the variables for which we have different data type or different code list or origin being defined for different scenarios. We also mention the QVal information, the subcall information as well in the variable level. Here you can see that in case of subDM, we have created 5 different QNAMs. So for all these 5 different QNAMs, we have created one record where the QVal will be the result, not the result, but the variable which captures the answer to that particular QNAM. So here you have the QNAMs, the records being created for subquels where for subDM QNAM equals to race 1, the QVal will have the length of 41, which is a text, which means the character variable, and we have a cold list applied, which is the race here. Again, if you noticed here is that although the information of code list origin are same, even the page information is also same, the data type is also same, but since we have different QNAMs for the different QNAMs in the subquel DM domain, we have one row created for each QNAM. So in this way, you can create the value level tab as well. If you have any further questions regarding to the value level, please let me know in the comments tab and I will explain that as well. Now we have seen the code list tabs as we have gone through the dataset variables or value level tab. So you can see that in the code list tab, we will have a ID, which is being mentioned in the code list column in the dataset variables or the value level tab. And then we have a name of that code list. And if it is a CDISC defined as GTM terminology code list, then we will have the NCI code list code, its data type, the terminology version. Then we have the terms, their decoded values, and the NCI term code coming from the SDTM terminology. But in case it is a study defined code list, then we will not have the NCI code list or the NCI term code here, but we will have the rest of the information populated. Now comes the dictionaries tab. Dictionary tabs gives the information of all the dictionaries like the Medra dictionary, the Who Drug dictionary, or any other formats which we have used in our study. That information will be mentioned here. So in this study, we have used the Medra dictionary and the SNOMED dictionary. So the idea of that, the name of this particular dictionary, the data type, and the dictionary versions will be mentioned. In the variables level tab, we should have a dictionary. It's not there, but in the earlier versions of Define, we do have the dictionaries columns as well in the variable level tab, but right now they have removed it. So another thing is that we have also mentioned any format which we have applied on any variables mentioned in the dictionaries. You might note that for the country variable in the DM domain, we have a ISO 3166 format applied. So we have mentioned that format here as well. Same is the case for the null flavors format, which we apply on the TS val variable in the TS domain. Methods, as we discussed, is we will have the ID, the name of that method, the description, which is the derivation logic mentioned in the description of the method tab, and in the comments, if we are having any particular comment for any particular domain or on a variable level, then we will give an ID to that comment and we will have the description of that comment. The last tab is the documents tab. So while generating the define.xml, if we will have the option if we want to attach any documents related to the study. The most common documents which we attach in Define are the ACRF or the SDRG. So right now we will give the one ID for each of the documents, the title of that document, and a hyperlink of that documents. So right now, I have attached the ACRI, which I have just shown you, and I have also a CSDRG created for this study. So I have given the PDF hyperlink of that documents in the Define, and I have created this Excel sheet. So right now you can see we have updated the Define spec, which was originally generated by Pinnacle 21. We have filled the respective information here. So the next step will be to use this Define in our Pinnacle tool. So let's move back to Pinnacle here. The next step, let me first close this sheet. So let's move back to the next option, which is the generate define using the Excel spec. So as we have a final version of this spec, so we can go in the Pinnacle define.xml drop down. From there in the generate define, we can select the define standard. Right now for my study, I have used the 2.1 version of the define.xml. So I will select the 2.1. You can choose either 2.0 or 2.1 depending on which version your study is using. So I have selected 2.1, then I will browse the spec which I have just created. So this was a spec which I have just shown you. I have created, and then after that I will be clicking on the generate button, and it will generate the XML file. It has come. Let's open the define.xml. So right now, if you face this issue that when you are opening the define, you are having a blank page, then what you can do is that uh, in the settings, you might have the reload in internet browser mode enabled. If it is not enabled, make sure that you go into the settings and enable this reload in internet browser mode option. And once you do that, it will be enabled for you right now. As you can see, for me, it is enabled. And if I click on this reload in internet browser mode, it will load the file, the XML file here. So you can see that my XML file is generated. I have all the hyperlinks here. If hyperlinks here, and the data sets, if you see, I have selected gone to A hyperlink here, then it is showing me to the A adverse event, the value, this is the dataset tab. You can see that we have the variable information, the label information on all, and along with it, we have the variable condition, where condition. And if I go on the where a term hyperlink, it will go to the where clause tab, which was the variable level tab, and it will show me that for injection equal a term equals injection site direction, what was the length of it, and if there was any comment assigned, then it will come in the comment origin source method. All these fields will come in this field. So let's go to the top and explore more on it. You can see that the study name, description, and protocol name all are coming from the define tab. We have the SDTM IG version also mentioned, or the any standards which we have given in our define that are coming here, and the data set tab which we have created, or they are giving all the information of the data sets in our study, and you can see there is a hyperlink for each data sets, and we have a XPT hyperlink for the A data set or the respective data sets. If I click on any of these hyperlinks, let's go. It goes to the next information, which is it is a combination of your variable as well as the value level and code list methods or the comments tabs. You can see each and every information here. So you can see all the variables which were defined in the A data sets, their label, their data type, if there is any cold list or format being defined applied on particular variables. As you remember, the domain was having a SDTM domain abbreviation, so they have a cold list mentioned, that cold list mentioned here, and it is having a hyperlink also. So if I click on this hyperlink, it will go to that particular code list value and will show you that, okay, what was the value in that code list. So you can see that for domain a origin domain underscore AE code list, I had only one value, which was the AE value, and it's decoded value, which is the adverse event. So similarly, let's go back and see for some other. In the origin source method column, you will have what the information which you have populated. If you have populated the origin, it will give the origin, and in brackets it will give the source information. If you have applied any method, then it will give the method information as well. As you have, if you might recall that for A sequence, we have given the origin as derived, and we have given a method of SEQ, and in the methods tab it had the description. So the description of that method is being displayed here. Or if in case we have given any comment also, then that comment will also come here. So you can see we have the information. In case you have the origin as CRF annotated or collected, then it will also have the hyperlink to that page where it was annotated on CRF. So in this way, you can see that the define is being created. This is the units here. Like if you click on the units code list, then it will go to the units code list and will give the information of all the values for that particular code list and their decoded values as well. So that's all for today. Let me know if you want to know any other details while for creating the define.xml, or if you have any other topics for me to cover in the next video, do let me know in the comment section. Thanks for watching.